Hello students, welcome back to your online session for physics class for today. Now today we are going to first of all recall what we did in our last class on Friday. So on Friday we began with chapter number 3 and the name of the chapter is force, and we also saw the objectives and then its introduction, and then we also learned about the concept of force. What is force? See, in this picture we saw that this man is unable to take out this car from this snow. Why? Because the force is not enough, and there is a concept of friction also that we are going to learn and study little bit later on in this chapter. Okay, then we also saw the definition of force, right? Then this activity regarding this push and pull concept, right? Then forces due to interaction, and in this we saw the concept of push and pull and the force, like how much force is needed to apply to move this car, right? Then the points regarding force means for push and pull what all we need to do. And okay, then we saw with the help of these pictures we also saw the concept of push and pull, pushing and pulling, right? Now today we are going to learn about more about force. Let us try to investigate it. For this, let us perform the following activity. Try pushing a table all by yourself. Can you move it? Obviously, it does not. It means with the help of this picture, what they are trying to show that these two kids are trying to push or like to move this table, but they are unable to. Why? Because they are not applying the amount of force that is needed to move this table. Let us take one more example. I hope students you all can see this almirah over here, right? Now if I'll ask you to move this almirah from this place and to just drag it and keep it somewhere else, will you all alone be able to do it? I don't think so, and the answer is no, right? But then if I ask you to take the help of your elder sibling, elder brother, I think yes. Why? Because you will be added with more force with you. Your brother will with moving this almirah. So after taking help of your brother, you will be able to move this almirah, right? But without anyone else help, you won't be able to move it. So this is how force works. That after taking someone's help, that force will be added up. You will have some other person also for your help, and you can be able to do it easily. So this is what they are also saying. Now take the help of your friend and try pushing it again. Does it move? You will find that it does. So what happened earlier? Only one of the kid must be trying to move this table, but that kid was not able to move it. Then what they did? They took help from another person, and then we can see that they will be able to move it very easily. Now you will find that it does. Now this means when you apply force in the same direction with direction, the force adds up. This force now moves the object in the direction in which it is applied. It means yes, in the direction that in which they will apply the force, this table will definitely move. Okay, now we will see this second picture. Let us read first of all about it. Now try pushing the table again. Ask your friend to push it opposite to the direction in which you push. What they started doing? One person is applying force from this direction and then this boy is applying force from this direction. What will happen? Will this table move? According to the concept, it will not move because she is trying to move it towards this side and he is trying to move it towards this side. So what will happen now? Will it move? If it yes, actually the answer is yes. It will move. But what is the condition over here? If it moves, then in which direction it does so? Obviously, it will move in the direction in which a larger force is applied. So it means actually this table will definitely move, but in the direction in which more force is applied. And according to this picture, we can see this girl is elder and this kid is still small, so he won't be able to apply more force than her, right? She can apply more larger force. So it means if the table will move, then it will move towards this direction because she can apply more force, right? Now, can you identify the game being played in the given figure? It is called tug of war. Actually, the figure is in next page, so we will see it. In this game, two teams pull the rope in the opposite direction. The team which is able to pull the rope harder wins. Sometimes the rope may not move. Does it mean that no force is being applied? Now see students, I hope you all can see this picture very clearly and you all remember it very well, and you all must have seen this game also, which was being played in our school during sports time. This is called tug of war. And why like concept of force is being applied over here? Because there used to be a team of 5 or 10 or 11 members in each team, right? And all the members of each team used to or try to pull the rope towards their side with their full force. It means by applying their full force, all the members of each team tries to pull this rope towards their side. But then what happens? Which team used to win? The team in which from which larger force is applied or more force is applied than another one. That team used to win this game. Okay. Sometimes the rope may not also move because why the rope will not move? Because from both the sides equal amount of force is being applied. It means the force that is applied from this side and the force that is applied from this side is equal. So that is why no one used to be able to move the rope towards their side. So does it mean that no force is being applied? We will come to know about its answer over here. The above example tells us that force applied in the same direction adds up and force applied in the opposite direction is subtracted. Yes, now we can also say that whenever like the force is applied in the same direction, it adds up. Adds up means it helps us to move the object very easily. But then if we apply that force in opposite direction, it is subtracted. Subtracted means that we won't be able to move it in one direction because same amount of force is being applied from this side and from this side. So it means it will be subtracted. Now does it mean that no force is being applied? The answer of this question is that it is not that the amount of force is not applied or no force is applied. It is not that, but it is just that the equal amount of force is applied from both the direction. That is the reason that the rope may not move. Okay, the net force is the difference of two applied forces. Thus, we find that force has both magnitude and direction. It means the force is having magnitude and it also have direction. If more than one force act on a body, then the net force acting on the body is the vector sum of all the forces. It means if more than one force, like if there are like many people who are actually applying force on any object or any body, then the net force acting on the body is the vector sum of all the forces. It means if like there are four people applying force on any object, then what will happen? The net the vector sum of all the forces will be calculated, and that will be called as net force. You will learn about it in your higher classes. Actually, this vector sum and all these terms, you are going to learn about it in your higher classes. Now we'll see effects of force, like what all are the effects of force. A force can change the state of motion of a body or its shape or both. It means a force can also change the state of motion. It means like if some body is at rest, then if I'll apply the force on this body, it will move, right? And then I can also change the shape of the body, right? The motion or the shape of the body. Like see, this is a pillow that I have. This is the actual shape of this pillow. I can, by applying the force, I can change its shape. This is its shape now, and I can also change its motion. Right now it is kept over here, and after applying force I can change its motion, means its state. So I have changed the shape, I have changed, right? And then this state I have moved it from one place to another. So this is what is the main effect of force. Okay, now first point we'll see 3.4.1 on mass of a body. Force does not have an effect on the mass of a body. Mass is an inherent property of a body. Yes, mass means the weight. Force, by applying force, we cannot change the weight of the body. Right? Then on speed. Place a ball on a table, gently push it. What happens? Does it move? Yes, it does. Whenever we keep a ball on a table and we just try to push it gently, then obviously it will move, right? So now push the moving ball again. What do you notice? Do you notice any change in its motion? Does it move faster than before? Let us take as an example, like with the right now I don't have a ball, but let us see it with a pen. I have kept it over here, and right now see it is moving, right? And then if I'll gently push it, it will move. But obviously, ball is circular, is spherical, so it will move. It will constantly move. This pen though is stopped over here, but it will constantly move. So, but when we will uh, push it once again, it will move faster. We can see over here, we find that if we push an already moving ball, it begins to move faster than before. Now place your palm in its path. If the ball is moving from this place towards this side and we'll place our hand over here, what will happen? What will happen? Allow the ball to touch your palm gently. Remove your palm as soon as the ball touches it. Notice the motion of the ball. Does it slow down? Yes, it does. If a ball is coming from this side towards this side and I'll keep my palm over here like this, so what will happen with the ball? It will slow down, right? Thus, we find that when a force is applied to a body in the same direction, its speed increases, and when it is applied in the opposite direction, its speed decreases. we can see that whenever we apply the force in the same direction, when we actually touched the ball towards the side in which it was moving, the ball started moving faster, right? But then when we applied the force towards opposite direction, like this, what happened with the ball? Its speed slowed down, right? So this is what they are saying. And when it is applied in the opposite direction, its speed decreases. So in other words, a force can increase or decrease the speed of a body. Okay, so by applying the force, we can also increase the speed of a body, and by applying the force, we can also decrease the speed of a body. Okay, students, is it all clear to you all? Now, what you are going to do, you have to read this part from here to this point. Okay, 3.4.2, till here you have to read it and try to understand it by yourself, and go through the video very carefully, and even then if you have any doubt, you can ask it from me. Okay, these points we will discuss in our next class. So that is all for today. Have a good day. Take care.